Hi everybody. This is Nawal. Again, we are back with another lecture on calculus, that is limits. Okay. First you will know what is limit and why it is used and where it is used. Okay. First of all, what is limit? What we do, what we learn, and what we teach, that limits exist when the variable or the value approach. This is what is limit. Okay, so what is existing will be coming to. So why limits is used? So limits are used to determine if the function is continuous or differentiable, right? So limits are used to determine the function is continuous and differentiable. So this is the why of limit. And thirdly, the uh, where the question, the limit is used, where the limit is used, right? So let me tell you that the limits are used in checking the continuity and differentiability. So these are used to check and solve the questions from continuity and differentiability, right? So this was the what, why, and where of limit, right? So let us come and discuss more about continuity. So what is continuity? So let me take a help of a graph. So this is our xy plane, right? So suppose this is a function, this is a curve, which is y is equals to f of x, right? And we got 2 points. This is a and this is b. So if we mark the perpendicular distance from the curve to the x-axis, this is x-axis, this is y-axis, right? So can get a value we can get a value at y-axis, right? So this is nothing but change in x, and this is nothing but change in y, right? So what does limit teach us? Limit teaches it is moving from x to 0. So the change in y by change in x. This is what limit teach us. Now, what if uh, we can understand in a better way? So let me zoom in the graph, right? And let me draw a straight line from here to here, right? So this is the straight line. Of course, it is not, but uh, we can assume it is a straight line, right? Yeah. So this is a straight line. So what we can do, this path is the original path and this path is the shortest path, right? We can What we can do, if from this path, if we start moving closer, at some point of time we'll be at point B. Yeah, if we start from point A, if we continue moving in this direction, after some time we'll be at point B, right? So the time when we reach at B, the difference will be 0, right? And if the difference will be 0, then delta x will be 0, right? And if delta x is equals to 0, then x2 minus x1 approaches to 0. We can write it like this, right? Or we can write like this, that delta x is equals to x2 minus x1 is equals to 0, or x2 is equals to x1. This is the thing. Okay, so we can write limit x tends to 0 dy by dx. Okay, so this is what limit teaches. Now, when do you know that limits exist? When does limit exist? When does limit exist? So very basically, let me tell you that when, suppose this is x tends to a. What is x tends to a means? This means that x is slowly approaching to a. Okay, so this means x tends to a, where some function like f of x is equals to f of a, right? Here, if if left hand limit is equals to right hand limit, then if left hand limit is equals to right hand limit, then sorry for this, then limit exist. Okay, so what is left hand limit? What is right hand limit? So let me tell you that if the function the function, so let us suppose that this is the point, suppose 0. So if it is approaching from left side, will be termed as a negative, and if it is approaching from right side, will be termed as positive. This is the right hand limit and this is the left hand limit, right? So if limit x tends to a negative, that is approaching from left side, f of x, this is known as left hand limit. And if limit x tends to a positive, f of x, this is known as right hand limit, right? This is known as right hand limit. So as I told you that if the LH is equal to a RHL, that is left hand limit is equal to right hand limit, then the limit exists. So this is all about the concept of limit existence and limits. So now we'll be learning about the very famous rule that is known as LH hospital rule. Before that, let me tell you about the indeterminate form. Yeah, so indeterminate form. So indeterminate form, what is indeterminate? If a function after putting all the values, if it comes in this variance like 0 by 0, infinity by infinity, infinity 1 by infinity, 0 by infinity, or 0 into infinity, or infinity into infinity, then we call as it as indeterminate form. To solve the indeterminate form, we introduce LH hospital L hospital rule. So what is LH hospital rule? So what is LH hospital rule? So if let us say a function like limit x tends to a, f of x by g of x is equal to f of a by g of a is equal to 0 by 0 or infinity by infinity, that is indeterminate form, then we will use first derivative on numerator and denominator as well. So after the first derivative, the function becomes like limit x tends to a of f dash. This is the first derivative of f dash x by j dash, right? So providly g dash x not equals to 0. If again, if again it comes into the indeterminate form like 0 0 or infinity by infinity, then again use second derivative, the second derivative in both numerator and denominator. Yeah, so after that your function becomes limit x tends to a f dot dash of x by g dot dash of x, and we'll be continuing the process provided that g double of x is not equals to 0. After that we'll be continuing this process, right, till when uh, it is not in the form of indeterminate, right? So if the LH hospital rule is clear, let us solve some examples and questions that has appeared in GATE. Like first question, which was appeared in GATE 2003. Here given the function uh, f of x is equals to limit x tends to 0 sine square x by x, and the options are here, right? So let's just solve these questions, right? So first, if we put x equals to 0, then this whole function will be becoming 0, right? So that apply L hospital rule. So after applying LH hospital rule, which states that if the function is in determinate form, so we'll be derivating numerator as well as denominator, right? So after derivation, we got what we got. We got dy dx of sine square x by dy dx of x, right? Limit x tends to 0. So this become 1. So what we'll get, only dy dx of sine square x. So d by dx of sine, this 2 will be coming forward, and the derivation of sine square x is cos square x, sorry, cos x. So it becomes sin x cos x, right? Now limit x tends to 0 to sin x cos x is equals to, if we put sin 0 or cos 0, it holds become 0, right? So the answer will be 0. After that, let us will be talking about greatest integer, right? So what is greatest integer? In 11th or 12th we have heard about this, but we can't dare to tackle this question. Like, for example, taking 4.7, so we'll be doing the opposite of greatest. Yeah, we'll be taking the smallest. So if we see in the number line 4.5, 0, 4.7, 5, sorry, 4, this is 4, yeah, 5, and this is 4. Okay, if we see, so what is the greatest integer factor, right? So if we talk about the greatest integer, it will do the reverse. We'll be going toward the smallest one, right? Not the greatest one. So the greatest integer of 4.7 is 4, and we'll be mentioning in a third bracket, right? So we can write it as a, like, y is a function of greatest integer function. Let us talk about another example, like y is equals to 1.1. What is the greatest integer? That is 1. Let us talk about another. What is greatest integer of 2? That is 2. Let us talk about another example. Y is greater 1.5. What is the greatest integer factor? 1. Y is the greatest integer. Y is a function of 3.6. What is the greatest integer factor? That is 3. So this is all about the greatest integer factor, right? After that, let's see. So now we'll be learning about some useful results, which are hard to calculate, and it is calculated by numerical method computation. So after that, what is first one? So first one state that limits x tends to 0 sin x by x is 1. So integration of sin x by x is very hard and can't be done with pen paper. We use computation method, right? So that is the reason. Yeah, some of the results are calculated by computations. So limit x tends to 0 sin x by x is equals to 1. After that, second one, limits x tends to 0 cos x by is equals to 1. After that, third is limit x tends to 0 tan x by x is equals to 1. We'll be using this all properties or useful results to get the answer very fastly. After that, fourth is limit x tends to 0 1 plus x 1 by x is equals to e, that is exponential. And after that, limit x tends to 0 1 plus nx power 1 by x is equals to e power x. And after that, limit x tends to infinity 1 plus 1 by x is equals to e, that is exponential itself. And after that, limit x tends to infinity 1 plus a by x is equals to e power a, that is a is constant here, right? Constant, yeah. And after that, let us solve some more gate problems related to this. Yeah, so find the solution of the function in which limit x tends to 0 x cube plus x square upon 2x cube minus 7x square. So the function is given like limit x tends to 0 x cube plus x square by 2x cube minus, this is 2x cube, okay, 2x cube minus 7x square. Yeah, so how can we solve? What is the approach? So if we put 0 here, it is 0 already, and this is also 0, so it is in 0 by 0 form. So we'll be applying LH hospital rule. So After applying the first derivative or L'Hospital rule, we got limit x tends to 0, 3x square plus 2x. And in denominator, 6x square minus 7 to the 14, 1, 4, 14x. So after that, if we put 0 by 0, what is the thing? So this becomes 0, this becomes 0, this becomes 0, this becomes 0. After that, we will be applying again. So it becomes limit x tends to 0, 6x plus 2 upon 6 to the 12 x minus 14. So if we apply if we apply if we apply the 0 x tends to 0 here, this becomes 0, this becomes 0, we get 2 by minus 14, 1 by 7, minus 1 by 7 is the answer, and we got minus 1 by 7, b is the answer, right? B is the answer. So let us try method 2, another method in this. Limit x tends to 0, x cube plus x square by 2x cube by 7x square. So if we take x square common from numerator and denominator, what you got? X plus 1 upon x square from here also, so 2x minus 7. So x square got cancelled. Yeah, so what we got? Limit x tends to 0, x plus 1 by 2x minus 7. If we apply 0 in the x, so it becomes plus 1 by minus 7 is equals to minus 1 by 7. So again this. So next question, solution. Find the solution of limit x tends to infinity, sorry, alpha tends to infinity, in which x power alpha minus 1 is equals to, these options are available. So what you will do? So first we'll be check whether it is a form of indeterminate or not. So if we put 0 here and here, it becomes 1 by 0, that is undeterminate or indeterminate form, right? So what we'll do, will be derivative, right? Or telling you that it is a form of 0 by 0, right? Indeterminate. So we'll be applying, we have to apply LH hospital rule. So after that, what we'll do, we'll be applying like y is equals to limit x tends to 0, x alpha minus 1 by alpha. So after applying first derivation with respect to dx by d alpha, what you got, y is equals to limit x tends to 0, log x log 1. Yeah, after that y is equals to limit x tends to 0. If we put 0, this become 1, and log 0 is 1, so alpha becomes 1. Yeah, so applying limit x tends to alpha tends to 0, alpha and log x by 1. So if we put 0, this become 1, and what you'll got, y is equal to log x. So answer is a, y is equal to log x. And at the last question, yeah, solution. Limit x tends to infinity, 1 plus 1 by x by 2x is equals to how much, right? This is the question. So what we'll do, we can solve in various ways, right? So if we solve it normal way, like if x tends to infinity, then what is the result? So if we put here x tends to infinity, yeah, so this becomes 0, this whole term becomes 0, and 2 into infinity, that is infinity itself, right? This will become infinity. So after that, what will be left out? So it will be left out with 1 plus. Let me solve it for you, right? Limit extends to infinity, 1 plus 1 by infinity by 2 infinity. So this term becomes 0. So what we got, 1 plus 0 upon 2 infinity. So this is a form of indeterminate, right? 1 power infinity, indeterminate, determinate form. After that, what we will do will be, we can take approach of another way, easiest way, I will say is easiest way. So what we'll do, limit x tends to infinity, will be taking log. So after taking log, this 2 becomes the 2 will come here, 2 into 1 plus 1 by 1 plus 1 by x equals to log y. So how is this done? So y is equals to limit x tends to infinity, uh, 1 plus 1 by x and 2x. So 2 will be coming here if we take log 2, and this all becomes x, right? This is the method. So after that, limit x tends to infinity and equals to, 0.2, and now if we put infinity here, so it becomes 1 by 1 plus 1 by infinity is equals to log y, right? So this becomes 0, and it becomes, you know 2 into 1 by 1 plus 0 is equals to log y. So it is nothing but 2 is equals to log y, and if we remove log, we'll get e power 2, that is an answer, e power 2. So this is the method, this is the easiest method or approach you can solve. So we'll be meeting, and by that, limits is over. Now we'll be discussing about continuity in next video, and differentiability also in that video particular. So till then, take care, bye, have a good day.